lot of refactoring and fixing some old problems. So, if you are starting with some fresh new project, why not to do it right from the beginning? How many of you write tests? Okay, my goal for today is to increase that number. But what does it actually mean to have testable code? Actually, it means that it should be easy to set up a testing environment, that the code should be predictable and it should be manageable. Sometimes it's tough to make it in some old legacy big code bases, but I will show you some tips and approaches that will help you make your code more understandable, manageable, and reliable. Let's start with global variables. These variables are generally accessible from any part of the program. I won't talk about some exceptions because they don't change the whole picture. Oh, sorry. So the simplest example of global variable in Python looks like this. You have some variable on the module level and you increase it in some other place, in some function. Or it could be a class. It could be an instance of a class. And you're changing its internal state by using it in some other place. Or it could be even a database connection on the module level. And when you're importing something from this module, a new database connection will be created. So you could have this kind of side effects. But global variables are not bad, but they are often used in the wrong context. Context matters. We have to use the right tool for the right job. Let's look what would happen if global variables are misused. Having global variables makes it harder to set up a clean test environment because the global state is shared across the test runs. Here, the second test will fail because it used the same shared holder object that was modified in the previous test. Actually, which test will fail depends on the execution order, which is also a bad thing. Having global variables accessible by multiple threads often implies of usage some synchronization mechanisms. So here we are incrementing this shared holder value 500,000 times in two threads. What should be the final value? 1 million, right? But actually, it's far less. To make it work, we have to use locking to achieve thread safety. Now it's correct, but it's slower. Let's summarize. It could make your code less predictable and more complicated. It could be harder to debug, which means less fun. Or more fun, it depends on you, actually. If anybody can change it, you can't just rely on this stuff. But actually, you can't avoid it completely, because something is always global. Any ideas what would it be? Okay, for example, your runtime environment is global. All your OS, sys, logging, and a lot of different modules have a lot of global variables inside. And it's okay to have them, because again, the context matters. You have to use the right tool for the right job. It's handy to use global variables if your application is small and have few modules and doesn't introduce some complexities that I mentioned above. Or at least this complexity is isolated and manageable. So now I want to illustrate one dangerous approach that will cause you a lot of pain. Sometimes, to make things work, you have to multi-patch a module with a newly created object. So, who know what the multi-patching is? Any big fans? Okay, we like this stuff. Multi-patching is the dynamic modification of an object at runtime. Usually we use it to make some workarounds for some bugs or some third-party code that we cannot manage by ourselves. Or if you want to change some behavior or feature that acts not in the way we want. But anyway, here we have a separate module that uses the same shared folder object, and we decrement it. Here, in this example, we are using multi-patch feature from PyTest. It allows you to multi-patch something, some object, and roll back changes in the end of the test. This patch feature modifies this module, multi-patches it with a newly created object. So, it should be. Let me scroll. Yeah. So if you remove this feature, the second test will fail for the same reason as before, because it will use the same object. It will use the same object that was already modified. Okay. What's wrong with that? Basically, complexity grows dramatically fast, especially in a big project. Your integration tests would be weaker because they will test less real code and more fake one. Also, it will decrease the actual code coverage and make your test suite fragile because it will depend on the execution order. Basically, it could fix some symptoms, but it doesn't fix the problem. In large projects, it could lead to multi-patching an enormous amount of different modules. We should avoid that. Let's make it better. The global state of the previous examples was hardly predictable. So, let's change it and make it predictable and manageable. The first step is to isolate this behavior of when the object is initialized. We want to initialize it only when we need it, only in the desired context. Flask has a beautiful way of solving this problem. It's called init-app pattern. It allows you to isolate some logic in a separate object and also add some tear down logic to this state. So here is an example of test setup of a simple Flask application that uses SQL alchemy, and it uses patching here. So we are creating a new database connection and patch the module that we imported before. And this is how it would be with a Flask SQL alchemy extension. Now we have a separate database object which is initialized only when the application is initialized. So we put the database into the application context. And here we have our new shiny fixtures. We don't need any multi-patching here. We don't need to create a separate connection. So we have this global state manageable. However, the application is still global, and it's initialized on the module level. So basically we have a side effect on import. And if you didn't initialize the database before running the test, it wouldn't work at all. To address this problem, the application factory pattern exists. Basically, the idea is to isolate this behavior in a separate function. So here we have it, and it's the same but isolated. Here we can use it in our test suite. We have a separate fixture that calls this function. So now we have this behavior isolated, and we could parameterize it with different settings. So we got some flexibility here, and the application instance is created after the test session starts, so we don't have any side effects on import. We fixed the global state on the Python level, but the database itself is a shared resource. It should be the same, in the same state before each test run. Here you can see a couple of ways of doing it. You could just recreate the database for each test case, which would be slow, but will be really isolated. Or you could truncate all tables and recreate all DB level features like views or triggers and all this stuff. Usually it's easily handled by migrations, so it's not a big deal. Or you could wrap a test case into transactions and just roll it back at the end of the test, which should be very fast, but not as isolated as other cases, since you will have this logic on your application level. For example, Django has two different options to deal with that. First one is transaction test case, it truncates all tables. And second one is test case, which rolls back transaction. There was a feature, an approach that was used in the previous example, but wasn't mentioned explicitly. It's called dependency injection. So, for example, you have an airplane class, and you put all the logic you have in this class, all just flat, with no structure. Dependency injection allow you to separate or isolate some logic in a separate object and use it as a dependency for another object. So here we have an engine that contains logic about engine, and we have a dependency in this class, and we are injecting it into the airplane. So your decoupled execution from the implementation is kind of an inversion of control approach. And now you could just mock your engine if it's too heavy for your ordinary test, or you could test it with different engines, or you could decouple it in the way you want and manage it in the way you want. Also, you could isolate some really heavy logic in this class. Or it could be like network calls for some third-party service or some heavy computation. You could just mock the subject and test the airplane itself. Or you could test these engines separately. So it gives you more control over your code. When you're writing tests, usually you use some values as input, and you expect some values as an output. But if you're hard-coding these values in your test code, it makes it less extendable. And if you keep it separate, it will allow you to easily extend your code. For example, new test case would be added just as like a single line in the parameterized operator. bytest. So here we have dependency injection again, like first, second, expected features. It could help you to find some similarities in your code and then refactor it to build some reusable tools that could help you in the future. So it's easy to have new tests and easy to refactor. But what if your object is more complex than simple string? For example, if it's a SQL alchemy model, you could do it manually in some separate function, or you could use something like factory boy. Here you can see a simple factory for user model, and the usage is straightforward, just call it. Factory boy is very well integrated with gorgeous plugin called PyTest Factory Boy. Just register your factories and make sure that they are imported in your contest.py. And magically, you have two new features. First one is user factory is just a class that you create, just your factory. And user is the result of a simple call of this factory without any arguments. Check this out. PyTest Factory Boy provides a lot of different features that are worth checking. And now we are approaching to the most important part of the talk. I would say, if you will remember just one thing from the talk, it should be this one. Test-driven development, and just a quick recap, how does it work? First step is to create a failing test. Then you have to add new code or modify existing one to make the test pass. And then you refactor your code in your test, and then iterate over this process. So it's a beautiful and iterative approach for developing new stuff. For example, you're building a new API class, and you want to have some users listing. Okay, you just call this endpoint, and your test will fail. And this is fine, because you know why it's failed. Because there is no such rule in your application. And it is a minimal step. Just add this handler and your test will pass. Okay, but actually you need to have some users in the response. Let's use user feature from the previous examples. In this case, you just have to modify your handler. It should actually query the database in the way you want. Then this test will pass, and then you will go to another feature and do it in the same way, and so on. And in the end, you will have all your features tested. So, luckily, you will know if something will fail just by running your test suite. Just fix it and go to the next feature. It would be even easier with PyTest XD plugin that has this loop on failure mode. You don't have to rerun it, you just call this just -f. So let's summarize. Basically, TDD will save your time and consequently money, and will make you confident about your code, because even if it's something failing on production, you will add a test case for it, some regression test case. And it's easier to do refactorings and add new features, because you will know that it will not break any features that you have already, and it's safe to add. But it's not a silver bullet. It doesn't mean that you don't have to write other kinds of tests or use any other approaches. Sometimes it's just much more simpler to do it with the approach that you're comfortable with. However, consider adding TDD to your arsenal. It's worth trying to improve your development experience. And the most important part is the mindset. You should treat tests and testability as first-class citizens of your development process. Thank you. So, I will be glad to answer questions if there are any. Please.
How do you test network outages, timeouts, circuit breaker outages?
Okay. There is a nice library. For example, it's called responses. Yeah, it's called responses. It's integrated with Python. There's a small plugin, so you could just set everything you need in this library. Or there is a Betamax library, PyTest or request-based stuff. So you could just set up your request responses sequence and write it to some YAML file or JSON file and just replay it as a cassette. So it's possible. It's use smoking inside, but it works. It's possible to test any network request sequence, either responses or Betamax. Or you could just make some simple mocks with unit test mock if you want, but there are more powerful instruments for it. Thank you, guys.